Hi everyone, next we discuss classification trees. So the tree-based methods apply for classification problems in the same way as regression trees, but we have to use different error functions. Because regression problems, that we can use the squared residuals, but for classification problems, then response is categorical, so we have to use different error functions. And we have two popular functions. So one is deviance or entropy, and the other is error rate. So the deviance. So deviance is basically maximized likelihood. So negative 2 times log of maximized likelihood. So suppose a terminal node has ni observations, of which the lowercase ni observations have label 1 and the others have label 0. And suppose pi is the proportion of label 1. Then what is the maximized likelihood? So think about the case that we have 10 observations, so a capital Ni is equal to 10, of which 7 observations are label 1 and 3 observations have label 0. And pi, the estimated proportion of label 1 is equal to 0.7. And what is the maximized likelihood? So we have the 7 observations of label 1. So suppose the probability of label 1 and the probability of label 0, then we have 7 observations of label 1 and 3 observations of label 0. So we want to maximize this quantity. And actually you can find that if we maximize this with respect to this and this parameter, you can derive that the maximized probability is 0.7 to the 7th power times 0.3 times to the power 3. So actually in general, so it is described as this. So if we take the average of this over all i's, so all terminal node I, then multiply by negative 2, then this becomes deviance. So another way is error rate. So this is relatively simpler. So we just count the proportion of observations classified incorrectly. So if this error rate is small, then this is better tree. So usually the deviance has a better performance out of sample performance because error rate doesn't change much, especially if the number of observations is small. So general case for K categories is in the textbook, so we only discussed the binary case in this slide. Okay, see you then.